to have my very first lecture to discuss with you all. Okay, it's still in the introduction, but it has a number of things that we will discuss together. And the very first few lectures until we can start some serious, not very serious, but some are fun, some activities together. Basically, it would be kind of lectures that I will just give the lectures and provide you background knowledge first for the very first session. Okay, since from our course, it is information system development and management, right? So the introduction part that I'm giving today, I finished this slide. And the very first thing is the word information system, right? We know system. What is a system? In your understanding, what is a system? Is it the first time you heard of the term system? I don't think so, right? But do you know what does it mean by a system? Any idea? Feel free to share in the chat as well. For those who is online or who are online. Okay, I think you have heard of the word system, right? What, if not computer system, if not information system, what other systems you have heard of? Security system, still very technology. Okay, yes, that is also possible. Thank you. What else you have heard of or you have known of? Again, please. I don't hear properly, sorry. Sorry. Embedding system. Okay, embedded system, sorry. Okay, still, yes, you are ICT, mechatronics and technology engineering student. Yes, embedded system, security system, networking system, telephone system. What else? Okay, so you're trying to define system, right? Okay. Thank you. How about, have you heard of solar system? Do you know solar system? Is it a system? Does it follow your definition? Okay. What about digestive system? Do you have respiratory system? Okay, this is also system, right? Not only engineering system that you have learned or known about, right? There are still many other kinds of system that they use the word system too. Solar system, what else? If not engineering, technology related system, what else in terms of system? I gave also some biology related stuff, physics, astronomy related stuff, right? Like solar system. Anything else? Economic system, is it? Have you heard of it? Economic system is also there, right? It's not the term that I coined myself. There exists. If you search, you'll find the term properly existing for sure. Okay. So anyway, when we talk about system, here is the system theory. Digestive system indicator. Okay. If we refer back to when we studied science, when you were much younger, you studied science, right? Have you heard of system theory that has input process output, and actually there's also a feedback. And in total, it is the environment. How can I remove it? Okay, so a definition of system is that, in general, it is a set of components interacting with one another and serve for a common purpose or goal. So these components within the system, they are interacting to each other, right? They are not very independent and do things on their own independently. No, they are dependent or related and so on, some of them, and are together, are formed together, or you call them because they're formed together to do something for a certain purpose, right? Think about digestive system. What are the components of digestive system? Okay, you said digestive, right? Okay, what are the components we have in the digestive system? Yes, those are the things. And the purpose of digestive system is to digest, to digest the food, give nutrition to the body, right? And so on. If we talk, then we apply the same definition to information system. So what is an information system? What components? Then first you need to understand, when we talk about information system, what are the components inside the information system? And yes, input, output. So that means what? Keyboard, mouse, this is input. Computer, screen, monitor, this is output, or what? Information, data, right? Okay. Components could be more. Hardware, software, these are components in information system. What else? People, are they part of information system? What do you think? In an information system, do we have people as components? Or we think of only hardware and software? Yes or no? Type. If you're online, type. If you're not online, think and say. Okay. Data, is it part of the information system? Data is not hardware. Data is not software. Data is data, right? So what I said is data, hardware, software, people, whether you think they are part of the information system or not. How about what else? Is that all? You need only this to be information system? What is the purpose of information system? It depends, but of course, if we talk about what information system you think you have, give an example of information system. What is it? Yes. Human resource system, right? It has to be system, not human resource in general. How about student information system? You see the name, right? Student information system. If you say no, I think you need to really consider something, right? The name already told you that it is information system related to students. You all need to use student information system at AIT, right? What is the purpose? Okay, so in general, we could say that SIS is for managing students' information, taking care of their study records, right? Basically, this is the main purpose, but study records management means enrollment, dropping, adding, grade result, and so on, right? Okay. What are components of information system? SIS. There is the system software, right? There's, of course, you need hardware to connect to it. Do you need data? And also your own data, right? Not only username, password, your name, your email, your study record, your grade result, and so on. Even your advisor, right? These are the data. What else? Database. Yes. Database is a kind of software, right? Okay. Function of what? But function is a software, right? Software means it defines what user can do. Click here to add cost, click here to drop cost, click here to log in, click here to change password. These are functionalities, right? But they are part of software. But I'm talking about main components. Then people, are they part of this SIS? Do you think so? Right? People. Without people, how do you operate the student information system? You need user, you need admin, you need database, maybe backup staff, you need many people, help desk, okay? You need advisor, student, secretary, they are the users. What else you need as components? How many credits you can register per semester? 15 maximum. Once you register, who is approving? Advisor. These are called process. You need the process, right? It's not like you out of something, you just develop information system. You need business process so that you develop your system according to the business process. So when we talk about information system, that's for sure the way it works is that it has input, process, and output to do something, fulfilling some goal. It needs the environment that relate to several stakeholders, such as customers, such as suppliers. If this is about selling things, buying things, purchasing of this, or manufacturing, you have supplier, you have customer. You may have regulatory agencies to govern the way you do your business, the way you work on your information system. Shareholders, competitors, these are things in the environment. But if we go to the information system in detail inside, there are combination of people, information. Okay, there are combination of people, information, technology, business process, and so on to accomplish business objectives. These are things related to information system. And actually, if I try to break down in detail, we will see main components. We already discussed, right? And you agree, you share your view as well. Hardware for sure. You cannot have information system without hardware. Hardware, software, data, procedures or process, and then people. These must be there. Have you tried to think of some samples of information system that lack any of these components? Any information system without hardware? Can we? I don't think so, right? Can you have an information system without any hardware, without any software, without any data, without any people, without any process or procedures defining the whole or how system works? So these are must-have components of information system for sure, right? Okay. And when we say that people, keep in mind that they are not only users, but also, even as I said, supporting team like help desk, programmers who may need to maintain or correct the system if there are certain bugs. There are people to do the training. There are people to admin the system and so on. Okay. So if we are to make a definition of information system, we can say that it is an assembly of hardware, software data, procedures, and people that interact. Then I have a problem. Where can I hide it? To produce information. Okay. All right. Why producing information? Can we use information to do something else, not producing information? Pardon? To be understandable. But does it produce information? Yeah, in a way, right? In a way. It will involve taking data, processing, following certain procedures, and finally producing some meaningful information to serve certain purpose, okay, of that system. Okay. So if we try to categorize these components, you could see that we have hardware and software. These are the computer side, right? They are computer stuff. If we talk about people and procedures, they are human stuff. They're related to human. People are human. Procedures are things that humans define, right? These are human side. So data is something in between, of course. Human produce the data, computer system, hardware and software process the data. Okay. So if we think about who are the actors, of course, hardware and people are the actors making certain actions, right? Software and procedures are kind of defining instructions. We develop software to follow or to behave in a way that follow the process of procedure that human define, right? Okay. I think this is kind of easy and very basic, right? You have data, we make the data input into information system to produce meaningful information. I need to emphasize that we want meaningful information. For what? Actually, to support decision making. Everything is related to decision making. Whether you're making a plan, it's a decision. Whether you decide to do something, it's a decision, right? Whether it is in any kind of level of decision, there are kind of basic level, strategic level, managerial level, they are decisions. So we use information system. We develop information system to support decision making of human users of business. Okay, so since we have to take data as input, feed it right into information system, produce meaningful information for humans to make decisions. Then it's very important that this must be quality data. Otherwise, you cannot really produce meaningful information. When the data is wrong, anything out of it is totally nothing, a waste. You cannot say that, oh, it will be semi-useful. No, it's wrong. When I say that it's going to rain and it's not, then whatever you plan will be wrong, right? When I say that today we have a class at 10:30 and it's not, then it's totally wrong. You make decision wrong, okay? So quality data means, first, people concerned about correctness. When you know something, it must be correct. People ask you that, hey, do you know Dr. Shutipon's email? If someone gives you something wrong, is it useful? No. First must be very correct, accurate, then it can be useful. Second, timeliness. I mean, I'm not going to rank the importance level, okay? They are all important, but second in this case, second to discuss. Not only it's correct, but it has to be timely. You need my email or telephone now because you have some urgency. If it is not in time, such as you want to get my suggestion for course registration, and the deadline for course registration is this Friday. If you don't get any input from me within the time, I tell you next year, my suggestion for you to take my course. Is it useful to you? You need it within this Friday to make decision. If anything I give to you is next year, sorry, professor, you don't need to answer me anymore. It's done, right? Deadline passed. It's not timely enough. It's like when you want to, have you invested in Bitcoin, block, in kind of cryptocurrency? You want to buy when the price is low. You want to buy when it's kind of having good trend, right? If you don't know such information, then or what you know is the information of last year, there is nothing, right? Even not last year, but yesterday, it's too late already. So timeliness is important. Completeness, some of the data must be complete. Otherwise, it's no use as well. Consistent, reliable, not ambiguous. Okay, these are also key quality of data you need to have to ensure the quality of meaningful information you will produce by your information system. Okay, next I will just summarize in terms of importance of information system in terms of business and organization. You see here, if we talk about business, how we do business today, if there still exists some business that do things manually, manually means no computerized system to help automate things, what will be a problem? Pardon? What will be a problem? Some problems? Okay, there, I think you can write down 10 pages. If I ask you to write an essay, what would be problem if a business is doing their work entirely manual? Okay, there are a lot of things that could be a problem. Competitive advantage is not there. It will be slow, maybe some accuracy of processing. There will be human errors easily, right, in every of the process and so on. Okay, I'm not talking about something like cooking food, right? Sometimes this is an art, right? That we want human to cook. I'm not replacing human by that thing, but I'm talking about business, transaction, and so on. That computer can replace or automate the task. Okay. Okay, so we can see that information system is kind of a heart for the organization in terms of organizing stuff within the business, in terms of and there are, okay, sorry, these are the dimensions that involve with information system within the business. We need proper technology, we need proper management, we need proper organization for information system. And information system support every level, can support every level in a firm, every level of operation management. In terms of the lowest one, operational management, you can use information to support daily routine, business routine, right? Such as SIS, this is operational. It just allows you to register, add, drop, view your results, change your profile. This is operational. In the middle management, it allows us to do some kind of analysis. How many students get A's? How many students are on probation? How many students are female? How many students are from Southeast Asia? How many are from Europe, and so on? These are kind of middle management related for maybe some proper planning or action. Also, there are levels of information system to support the senior management or executive, okay, to make even strategy, future long-term plan, and many more. So actually, these triangle follow from this one. You could see that I try to give this dimension of information system to map with the types of decision that the system can support, and also the type or the level of the management people in the firm. So if we talk about operational level, okay, the information system, the types of information system are transaction processing system, such as 7-Eleven. Transaction processing system is what? What is it? If we go to 7-Eleven, do we have any information system in the transaction processing level? In the transaction processing level, what is it? Pardon? Okay, we call it point of sale. Just to record what customer buys, right? At what time, at what day, and who buys what, basically, who buys what and when, and how much. These are key things. Okay, if I talk about 7-Eleven, it is the point of sale. In terms of the middle management, what can we get from this? This could be unit manager, sales, tactical management, or kind of middle management. So if you think of 7-Eleven, this management level could be a manager of the 7-Eleven shop. What kind of information system we could think about that support this kind of 7-Eleven manager? So we want to analyze which products are most interested, are most buying, top buying products, right? So you should stock more of these things, right? What promotions would be useful for this particular branch and shop? What are popular time? Sometimes there are seasons of the things, right? These things could be sold a lot during this period of time. The other things could be popular during the other period of time for different groups of customers too. So segmented marketing, sales promotion, and so on could be planned based on such data analysis. Okay. Sales report, summary of sales report by month, year, customer segment, and so on. Okay. Then in this level of the strategic management, what can we do? What type of system? Maybe for the 7-Eleven of the headquarters to see the global trend, the national entire country's trend. What to do? It's not like what to sell for this local, for AIT students, right? It is not the top management of 7-Eleven would decide, right? They want to do something beyond. Okay, more of the strategic level. Whether how many branches we should open in total, what are the optimized number of branches? You open too many, you're competing with each other as well, and so on. It's more on that level, not to get the most profit from each branch. That is more on the middle level, right? Okay. So all of these levels will have different types of information systems to support, right? So the input, process, output of different levels are different too. Okay, so you need to be careful to clearly understand, right? For transaction processing system, this is just for routine business transaction. Like you go to the bank, what is the IS for the bank? To support what? Opening an account. What else? Withdraw, deposit, transfer. These are key things, right? And they are just transaction processing system. Whether you do it at a bank, you do it on a mobile phone, you do it on the internet, fine. But they are still transaction processing system. For customer to do transaction, for user to do transaction. When it is MIS, Management Information System, it's for maybe the branch manager to see that what types of accounts or products are mostly popular for this branch, for the users. Who are the target users? How much of withdraw or borrowing money? And also bank has loan as well, right? What is the loan trend for loan, for deposit, and so on. The bank may need to understand this thing. Decision support system for the top level of the bank would be to understand the whole country's trends and so on, and think about new products for the whole bank itself. Okay, so this is just the same, but I do that. I show here that you can even divide this into different functional areas, because if you are human resource director, you may want to different types of transaction processing systems should be here, right? Such as to record employees profile, to record the performance of the employee at the company, to do things related to compensation, benefits, and welfare of the employee, and so on. And what would be this and this for different functionalities, okay? Actually, I do have some available, okay, but you look at this as some example. If we talk about sales and marketing, there's the order processing system. We may have sales management system. In the middle level, we may have like 5-year sales trend forecasting for the top level. If you think of human resource, as already mentioned, we may have like employee record keeping. We may have like relocation, cost control, contract cost analysis, and so on. And we can have here company personal planning, and so on. So these are examples of different information systems supporting different functions in business and for different levels in a firm. Okay. Okay. So next, I would like to, do you have anything? Okay. I would like to talk more on this component. When we talk about software, it's one of the most, not most, but one of the important components. Because usually when I say the word information system, I think most of the time you think of software. Am I correct? You ignore other components, all the other 4 components, but your focus more or less is on software. Why? Maybe because you are ICT students, right? When we talk about a system, oh yes, we need to develop a software for that system, right? For example, we develop the POS for 7-Eleven. It's your job, right? Oh, okay, hire me as a programmer to do the POS system or something like that. So maybe that is one reason. And secondly, software is something that takes some time to develop. It's not for everything that is kind of available on the shelf. Not every software is on the shelf, right? Hardware, you can go to shops and order and buy. Software, it really depends. Okay. So software as a component for information system is one of the challenging. Is a challenging factor for a successful information system because we usually have a number of issues. We cannot develop, we cannot find the right software or something like that. So that is the reason in our course, we will need to discuss a lot of topics related to software engineering and software development because they are keys of successful information system projects. Hardware you go and buy, okay? We will not talk about acquiring hardware in our course. We just assume that most of the hardware, even some hardware, I know that you may need to develop them, but they are part of the hardware people, okay? We leave hardware aside from our course. It's not gonna be a main focus. We focus more on the other components and especially the focus on the software. So I have these 6 questions. Please read them and spend 1 minute for yourself for each question and try to answer. I give you 5 minutes to think about 6 questions answer. Okay, I profit 1 minute. So I give you 6 minutes now. Try to think about answers of these questions. Don't go to the next page because actually solutions are there. But I just want you to try to think for yourself first Okay, are you ready to discuss next? Okay, so let's check your answer and the one we will discuss. So what is software? One moment. Okay, I do have definition, so I'll go pretty fast because these are still very basic stuff. Okay, when we talk about software, because it's part of the definition of information system too, so I want to be sure that we understand the meaning correctly. So one way to define software is that it is a computer program for sure, and also related to associated documentation. Software alone doesn't mean just give the program. So when you are a developer and develop a software, deliver not only the code and the compiled software, right, but also documentation, proper documentation. So these are good software. Good software must have both software itself and proper documentation. There are several types of software. Some are just specific software customized for specific customers. Some are general software that are used by any kind of customer, such as Microsoft Office, right? It's not customized, but you can ask some developer to make your Office, not Microsoft Office, right? That you have specific features you want. Attributes of good software, what do you have? The very first thing. Actually, there are many ways for you to define good attributes of software. Some of you may say that it has no bug. It should run smoothly, correctly, return correct results. Okay, these are easy, things that come up to our mind very first. But we have actually can define several dimensions, such as correctness of the software to return things or do things according to what users want. Actually is in terms of acceptability, because if the users accept your software, it means it do things in the way they want. Not only that it produces correct output, but the user interface, the way to use the friendliness of the software is also part of the acceptability. So if we are to define good software in several dimensions, I would say user acceptability, software efficiency. You don't need supercomputer to run all your software. Dependability and security, as well as maintainability. Okay, these are good software attributes. What is software engineering? For those who have you learned software engineering before? Tell me. There is a class in undergrad study for sure. Software engineering. Anyone learn software engineering before? Raise your hand, please. Hi, confident and proud. 3, only 3 from this side, no more? Oh, really? Oh, 4, 5. Anyone you know? How about this row? No. This row? No. 2 from this row only? And you don't? Do you, or you forget? You are not sure. Oh, okay. How long ago was it that you took your undergrad studies? Okay. Anyway, software engineering is the kind of, we define the word engineering here for software such that it is defined properly as, it's not defined. It takes, how do you understand when we say about engineering? Engineering process mean what? When we engineering some process. Pardon? To build something. But when the way we study an engineering discipline is that things should be defined step by step and repeatable, right? Suppose you learn civil engineering, you learn mechanical engineering. Those things are defined in a way that if you want to do things, these are step 1, 2, 3, 4, 5. These are engineering process. So again, for software, we don't want, when we are those who build and develop software, we don't want the programmers to be kind of very artistic. Oh, I feel that we do it this way. Oh, today I just start coding line 1, 2, 3, and then I continue this, and there's no kind of proper systematic steps. Okay, so software engineering is a discipline that try to take some kind of concepts from engineering to properly set the process, the methodology that, okay, to build a good software, even every software is so different. But to build good software, you must follow step 1, step 2, step 3, 4, 5, like this. Okay, so that is why it is called software engineering. So it is concerned with all aspects of software production. Okay. And what are fundamental software engineering activities? Basically, if you read many texts and many resources, maybe they are defined with different terminologies, explanation, and so on. But basically, the meaningful steps and process are the same. So important activities when we develop a software include software specification, software development, software validation, and software evolution. These are key activities. Inside there are sub-activities and process too. Okay, what do we do? And these are the things we will learn throughout this course in certain detail. Software specification means, again, we are in software engineering. So there must be proper ways to specify the requirements, the needs of the software. What should the software do? This is called software specification. It should, for example, take SIS. It should manage student profiles, including basic information, study records, study performance, and it supports registration and so on. So maybe these are the specification of what software information system should do, SIS should do, the software behind the SIS. So specification is to define what software to be produced, what requirements, what functionalities, attributes of that software, such as it should not take longer than 2 seconds. Suppose we want to talk about the efficiency measure. It should be fast. That means should not take longer than 2 seconds to load the thing and return the output to the user, something like that. This is also what is defined in the specification. Okay. The next activity is a group of activities related to the development itself, which include activities on the design and on the program part. Not only just coding, right? You need proper design, especially when software is big. You cannot just do the coding. You need architectural design. You need interface design, database design, and program design before you can go to the coding part. Then the validation. is the activity that involves validating that the produced software is what the user wants. Okay, this is important. Whether you write something the user wants or not, you write something you want, not the user wants. Okay, the last part is evolution. Software is not static. It needs maintenance, evolving to a new version, adding new functionalities and requirements. Okay. So all this process would be somehow iterative or waterfall, or there are many ways that this process are proceed to the next, but we will talk about that. Okay. But these are key activities that we need to understand first, and they all will be discussed and practiced within the course. Okay, the next question, key challenges. When you had your 1 minute time for thinking about this, what are key challenges you had in mind? Are they part of this? Key challenges in software engineering. Any one of you have experience in coding? Coding real system, not coding in a class and submit to a professor. In a work, be part of some team that develop some program or some software that is in use. Anyone? Yes? Okay, two. Anyone on this side? And how about the online? Any one of you? Okay, what did you code? What is that called? In Nepal, and it's still in use. The system is still in use. Okay. And which role of that system and software have you taken part of? User interface designing. Okay. How about you? Mon, right? You are Mon. Yes, okay. I don't hear. Website. But is that software or is just website with the content? What does it do? Pardon, what does it do? Image algorithm. Okay, so related to agriculture. Okay. What does the software do? For example, it shows the image, it analyzes the disease of the crop, or what does it do? Okay. All right, interesting. And the part you code that? Okay. Okay. That's also interesting. All right. So, do you have any challenges when you develop the software? What are the challenges? Do you need to work with the users? To understand the users? To what? Okay. How about you? Okay. were you the person interfacing with the stakeholders and user, or you were in the team and someone else interface and then discuss? Okay, yeah. All right. So what I explained here, okay, in terms of current challenges facing software engineering, what I listed here would be that now we are coping with increasing diversity, meaning that actually, there are a number of requirements in various ways, in various dimensions and so on. Requirements from users are very diverse. Okay, users themselves are also very diverse. Information system and software are also for different types of user, different types of levels in the firm and so on, right? So these are so overwhelming, okay? And the demands are increasing. They always want to get things done quickly. In the past, there might be time. I will show you the history of the software engineering from the past to now. Developing software could be said like 1 year project. Nowadays, nobody will wait for you to produce a software in 1 year and deliver it. They will just find another developer. If you say that your team can do it in 1 year, nobody wants. Okay. So reduce the delivery time is also a key. Every user wants things now. Okay, when they hire you, one thing that business people would ask or would answer if you say, when do you want it? When you were asked to do something, and then you ask the person that, what is the deadline and when do you want it? You know what is common answer? I wanted it yesterday. Nobody said that is the next month, next 2 months, next 3 months. I said 1 year, right? That is impossible too. So the business people would say, I wanted it yesterday. So the faster, the better. Okay. Also, they want trustworthy software. We will try to discuss all these challenges and what are current solutions to address these challenges in software engineering. Of course, you cannot change the demand. It doesn't mean that, okay, we reduce the demand from the user. The demands will still be huge and high. But what are techniques that we can use in order to overcome those demands and needs for the software? Okay. There's software engineering techniques and methods. Okay, this is to say that different software projects are different. You have no best technique. You really need to analyze from the requirement and the nature of the project, what techniques are the best for this project. Okay, and we will learn some of the key techniques. Okay, I go fast now. Okay, software engineering, the reason we learn it, well-defined methodologies. We need proper documentation, but not lengthy. We want our software to be maintainable, used for some time. Okay? We want a faster and cheaper way to develop large complex systems. Because if you don't manage and do well, you might overrun your budget. Software project failure. This is common. Not every software project succeeds. There are a number of software projects that fail, even big ones from big companies and so on. Okay, spend half minute. Think, what do you think could be factors making software projects to fail? What do you think? Yes, you can answer now. Pardon? Unstable. Unstable of the software. So it means the programmer develop it badly. So it's the fault of programmer. Okay. All right. So the programmers do not develop proper software. So it fails because the deliver software is something not good. Okay, that can be. What else? What is not clear? Requirements are not clear. And why the requirements are not clear? And that is to be, how could we resolve this when we say that requirements are not clear? And if we know this is a problem, what do we solve? How do we solve? Better communication. Okay, these are possible solutions. Okay, back to this, software is badly produced. What could be possible solutions? We are not analyzing only the reasons and factors, right? We should also think about solutions when we know the problem. Increase the salary of developers so that they could do better work. Okay. All right. There are a number of factors we will discuss. Okay. I will not go into the detail now, but those are some possible things that happen. Actually, also another thing, if not understanding the requirements well, could be one factor and important. But then size of the software is also one factor. If you are to produce small software, requirements could be easily understood too. Number of stakeholders you involve would be small too, right? When your software project is huge, likely the chance of failing may be higher. Look at this. But of course, it doesn't mean here is the peak. Maybe grant you pay more attention, right? Okay. But still, here, percentage of challenge project and fail projects are high when the size is not small and not manageable easily. Here you see, successful projects are bigger. But this is not only the factor, right? It depends whether you have good teams, you have good support from stakeholders, sponsor, you have proper ways to manage your project or not. And actually we will see as well, what do we mean by successful project? It will not just mean that you deliver the software, right? It would mean many other things too, such as you delay the software. You finally deliver, but you delay. Is it still successful? Okay. Types of software. There are many ways we can acquire software, right? Whether you have a package software, you just buy it. Whether you use your internal resource to make an in-house development, okay? Oh, this is in-house. this is outsourced of the IT service firm to outside. Whether use some open source software available, you just customize it, or we use it entirely. Use cloud software, use many other such as ERP solution and so on. Okay, I just go quickly. When you choose a software, these are the things you need to consider for sure, right? I think this is easy. Cost, functionality, support, viability, flexibility, documentation, response time, ease of installation. If you're supposed to buy is good. You just solve your problem with money. That's it. And then you get your software ready very soon. Okay. Okay, here is the part. I go quickly, but this is also important to understand. History of software engineering. Now we have discussed about, sorry, Alvin, I just saw your answer. Okay. History of software engineering. And this is based on this reference. Okay. A view of the 20th and 21st century software engineering. So I will divide this discussion into period of 10 years time. So each decade. Okay. Starting from 50, 60, 70, 90, and so on. Okay. So from the 50 and 60, actually, here, the focus and the highlight, the summary, okay, the key summary of the period of 50 and 60, 50 to 60, okay, is that it's kind of period for hardware engineering. Software world was not popular or was not the time yet. So software engineering is like hardware engineering. That means the process of doing or developing software focus on the way the concept is measure twice, cut once. Why do we say that? Because that time computers were very expensive. You cannot waste any single of instruction resource and so on. So you have to be very careful when you develop a software. Check every line, check every code manually. Even the time we did a software and program, we did on punch card, we did on this and that. We could not just trial and error, just run. I don't care, just click and run. And then we see if it is correct, it's correct. If it's wrong, then we will debug. But that time, you ensure every correctness before submitting it to the system, something like that. So it is kind of considered software engineering in a way similar to hardware engineering because computers were very expensive. Okay, and it was not convenient as of now. And then later on in 60, the software crafting has shifted the emphasis to development more than from the design, because here this time the design is the important thing. We spend a lot of time on proper design, checking, so on. Then the code and fix approach was introduced, okay, and software became more people intensive than hardware intensive. Okay. Okay, then this is where from the diagram here, actually, I zoom in, then you could see this is the hardware engineering method. Then we move to software craft by using code and fix technique. Then in the 70s, there are there were introductions of formal process, waterfall process, and so on. So these are waterfall process and formal methods in 70s that has been introduced. We will learn about waterfall process together. It's kind of very traditional. We just need to learn. But whether we follow it in certain case or not, it depends. Right? So we have the thing like modularity principle, structure design and programming, and so on, and the concept of information hiding, abstract data type was introduced around that time. And this is example of what we call waterfall model. It was introduced in the 70s, and it was very, it was one of the key process model in software world, okay, even until now, but has been replaced or obsolete somehow. So waterfall means we do steps of process from one to the next until we finish one, we move to the next and so on. Okay, so that is why it is called waterfall. So software development, waterfall process start from requirement, system requirements, software requirements, analysis, preliminary program design, doing program analysis, program design, coding, testing, and operation, and so on. So this is the step 1, 2, 3, 4. Okay, you do one after another. No kind of iteration, proper iteration introduced here. You need to finish the whole bunch of things first until you move to the next step. That is the waterfall model. And there was also analysis that if this scale, this chart tell us that how much does it cost if we detect something to fix in the software state. For example, if you know that something is wrong from the requirement phase, the cost, relative cost to fix it would be relatively small. But once you move on from this step to the very later step, and you found out that suppose it's in the development test, in the testing of the development test or the acceptance test by the user, the cost that you will need to fix your entire software would be high because you already go so far, right? Make all the specification, design, coding, and so on, and then you found out that, oh no, something is wrong. Then you need to go back to the beginning and change or fix everything. That is why the cost of changing the software will be high depending on when do you know something is wrong. Okay, earlier is the better. And in the past, portion in terms of the cost was on hardware. Cost of producing software is lower compared to hardware cost. But nowadays, even more. Cost of software development is high. Cost of hardware is cheap, right? That is the trend. Hardware cost is cheaper and cheaper and faster. But the cost to hire a development team for a big project and so on could be many million dollars as well. Okay, then move to the next period of productivity in the 80s. There are things such as object-oriented methods, maturity models, software maturity models, software factories, even post-GL language, post-generation language. user programming, and so on. So in this period, they are more focused on productivity and scalability of software. Okay. There are things such as test tools such as automated test case generator, unit test case. The reason of having all these tools available is to improve efficiency. Also, concept of software process. To reduce rework, concept of software reuse have been introduced and invented during this period. Okay. Object orientation, Smalltalk, ISO, C++, Java were kind of introduced this period as well. Okay, then we go to the next period of 90s, in which something happened such as, it's called concurrent processes. We have domain-specific software architecture. We have things such as agile methodology, rapid composition and evolution environment, so on. And more on the object-oriented field have been developed during this period, especially design patterns. If you were in the have been in the software world and have been taking software class before, I think design patterns is a kind of one things you need to learn. Okay? Similar to software architecture and UML, Unified Modeling Language. So these are just, I know that for many of you who are new to this, what I said, many of these things are just keywords that you may have not a clear understanding, but just to give you the whole picture of what has been going on in the past 70 years. Starting from 1950, right now we are 2023. Okay, the emphasis is on time to market. That means a shift from sequential waterfall model to concurrent engineering in order to deliver software faster. As I said, no more of developing software that takes you 2 years or something like that. Okay, so here you could see from these statistics, it says that month and year release in the past, it could be up to close to 50 and 60 months. That means how many years? 5 years to release one big software for one project. That's long. If it is now, we already changed our requirement. We already don't want that kind of software anymore, right? If we want to wait that long, somebody already do something. And it has been decreasing. Okay. And what happened? Okay, yes, from the 90s, one important thing is the rise, the popularity of open source development. Now this is pretty common, but it was there from 90 that there were Linux, World Wide Web Consortium, Apache, Python, and so on. These are the things that were introduced there as open source and making the open source concept becoming very popular. Open source software, I mean, because we want to developers want to contribute. We don't code only for money. We someone code it for passion. Okay, and they want the world to use their software as many as possible, as big as possible, such as Linux. Okay, there are things starting from this time as well, that is concept of usability and human-computer interaction. Increase the usability of software. Before, Okay, I should say this. I'm not sure you are in this different generation already. But since software was kind of difficult, right, to develop, to code, and computers are expensive, were expensive, then we developers had to optimize the resource, right? Spend less number of time on the server because it's so costly. The instruction to execute must be optimized, fast, and so on. Then we care most about coding, not about users who use it. So I make this statement. In the past, whatever program we wrote is developer friendly, hardware friendly, but not user friendly because we care. And oh, it is, if you write it this way, it's easy to maintain the program. But whether it's hard for user to use or not is your problem. But now we care more about usability, right? User experience, user friendliness. These are changing because technology change, hardware change, the very many things improve. Okay. There are concepts of rapid prototyping as well, just to let the user see the product as soon as possible. That is called rapid prototype. And then they can give comments whether they like it or not, they want it or not. This is the way they want the software or not. Okay, rapid prototype has been started from that time. Okay, two more, 20 years more. Agility and the values. Okay, this is the time. Agile method has been very popular. Okay, agile method and the manifesto has been, we have over there. These are all the agile manifesto. Okay, we will learn about agile in deep in our course as well. Okay, value-based software engineering. The focus and emphasis is on software and product usability. If you produce a software that is not used, then it's the waste of the whole project. It's not considered successful. Even you deliver everything entirely correct, no bug, everything so correct, but nobody uses it. That is a fail. Okay. And next, agility, model driven. What are the key things? Okay, these are the height. Gartner's height. Okay. I should highlight what? Unified modeling language is here. Business process analytics, rapid application development, and agile development. This is kind of the trend that time. Okay, then the last phase, okay, in this history is for the globalization and then systems of systems. Focus would be on connectivity, collaboration, okay, globalization of the team, and also enterprise architecture. Software is huge now. It's not just one standalone. It's the enterprise architecture. And the team, software team, are comprised of diverse workforce, meaning that it's very common to have software team comprising one in Asia. I mean, not one team in Asia, in Thailand, in India, in Nepal, in Myanmar, and also in Europe, and also in the US. We work across continent and use the technology to support this kind of collaboration on software projects, and it's real. It has happened for many years already, and has been boosted through the COVID time as well. Okay, and I think that's all for today. in terms of the introduction, the background, and everything.